So we've reached the last problem of the problem set we were solving. The last problem says that 1 mole of an ideal monoatomic gas is taken round the cyclic process ABCA as is shown in the figure. Calculate the maximum temperature attained during the cycle, and Prasoon will tell us how to calculate this.
So it is 1 mole, so we write PV equals RT and say temperature equals PV by R. Now let's just analyze at points A, and noting that T is directly proportional to PV, the product of pressure in the volume. At A, PV is P naught V naught, and then when we go from A to B, because the V naught is volume is V naught, it remains constant and pressure increases. So in the process AB, the maximum pressure PV value will be found at B.
Right.
And there it will be equal to 3 P naught V naught. And note that we are just comparing P naught V naught because that is directly related to temperature.
Right.
We divide P naught V naught by R and we get the temperature. So now let's see what happens at C. At C, what do we have is when we go from A to C, it is P naught V naught, and here the pressure is constant but the volume is increasing. So for the process AC, the maximum occurs at C, the maximum temperature occurs at C, and it is equal to 2 P naught V naught.
Right.
So now the only process left is the process BC. Right. In this we have to analyze, but we cannot directly analyze because both the pressure and volume are changing. So for this we will need a particular equation which relates the two, and then we'll analyze it. So let's see, consider a point PV in between, and we'll write the value of PV with reference to the data that we have.
Right.
So we say P minus, this is just like writing the equation of the line. So P minus 3 P naught whole divided by V minus V naught.
Right.
P minus 3 P naught, this one, this minus this, divided by this minus this.
Right.
Would be equal to this minus this, divided by this minus this. So P naught minus 3 P naught, which comes out to be minus 2 P naught, divided by V naught. So P is basically RT by V. We just substitute it. We get RT by V minus 3 P naught divided by V minus V naught.
Right.
Equals minus 2 P naught by V naught. Now what do we have here is that we have made this whole as a function of this temperature as a function of V itself. So using that we can find the value of V at which temperature may be maximum.
Right.
With the help of calculus alone, by the concept of maxima and minima.
Correct.
So we just go about solving it. RT V naught by V minus 3 P naught V naught equals minus 2 P naught V plus 2 P naught V naught.
Right.
Give the RT V naught would be equal to 2 minus 2 P naught V square plus 5 P naught V naught V. So T is basically minus 2 P naught V square plus 5 P naught V naught V divided by R V naught.
Right.
So we've come this far. Let's see now what else we'll do. Now we just differentiate it, that is dt by dv.
Right.
By doing this we wish to get a particular critical point where it would be maximum, where the temperature would be maximum.
Right.
So we can just simplify it further as 5 P naught V by R minus 2 P naught V square by R V naught. Okay. So dt by dv is 5 P naught by R minus 4 P naught V by R V naught.
Yeah.
Substitute it for 0.
Mm-hmm.
So using this, basically we find V equal to P naught gets cancelled, R gets cancelled, will curve 5 V naught by 4. Now we have to find temperature once we found V.
Right.
So this V is for T max,
Right.
and we can verify it by doing G2D T by dV2, which will come out to be a negative number.
Hmm.
So basically that will imply that that is a maxima, negative. So we just substitute this into the formula which we had, which is this one, which connects T and V.
Right.
So T max equals 5 P naught. For V we have 5 V naught by 4R minus 2 P naught by R.
Hmm.
V naught dot V square is basically 25. V naught is square by 16. This comes out to be 8, and this V naught gets cancelled. So the final answer basically comes out to be 25 P naught V naught by 8R. So the important concept in this question was that we had to find a relation for showing all the P and V in this, finding a relation between T and V through that,
Right.
and then basically using the concept of maxima minima in calculus to get to the right answer.
Correct. So guys, with this we are done with the problem set on kinetic theory of gases. Now you have caught hold of theory and both the solutions of the problems. You just have to keep practicing, because practice is what they say makes a man perfect.